All right. Let's do this. So a roller coaster that has a mass of 630 kilograms. That's the mass. Starts at rest. That means that the initial velocity was equal to 0 meters per second at a height of this way up here, 58 meters. So that would be h equals 58, right? Then it says, what is its speed? That would be the final velocity at a final height of 12 meters. So we'll call this the initial, and then way down here. So this is the initial. You guys pay attention. The initial height, and then down here, this is the final height of 12. Now this is a conservation of energy. So the kinetic energy plus the potential energy, the initial, because energy is conserved, that's going to be equal to the final kinetic energy plus the final potential. Now the reason that's important is because it's conserved, so that'll help us. So what is the initial velocity? So we have 1/2 times the mass times the initial velocity squared plus the mass times acceleration due to gravity times the height, the initial height, is equal to 1/2 times the mass times the final velocity squared plus the mass times the acceleration due to gravity times the final position.
Oh, I remember this formula.
Yep. So now we're going to divide everything by the mass, right? Because we said that the mass.
Because mass is a common denominator.
Yep. So all these masses will cancel.
The mass is 630.
Now here's the other thing too. The initial velocity is equal to 0. So this goes away completely, right? Because
is mg the force?
That's the force due to gravity, yeah, times the height. So then you end up with GH, and then remember that's going to be 1/2 times the mass, but we said the mass was, well, let me do this. Let's do it symbolically first. So it's 1/2 times the mass of the cart times the final velocity plus GH, right? Well, they're two different H's. So you're going to subtract G.
Look, the HO is the initial and the
Yeah, they're two different ones.
Oh, well, the H didn't have the O when I said that.
It says right there.
It just, but when I said that, it didn't happen.
So over here we get G times H, not minus H. That's how that ends up looking. Is equal to 1/2 times the mass times the velocity squared. Our goal is to get velocity by itself. Multiply both sides by 2.
And square rooted it.
So then you got 2 times G times the difference of H0 minus H is equal to the mass times the velocity squared. Almost done. Divide by the mass, divide by the mass.
I thought the mass was divided out originally.
Oh, yeah, you're right. I canceled that out a long time ago. And so this got canceled out a long time ago. So this would be the velocity squared, and then this is just the velocity squared. So then you take the square root of this and the square root of this. So you get that the square root of 2 times G times H0 minus H is equal to the velocity. So that'd be 2 times 9.8 times the difference of 58 minus 12. Take the square root of that.
Wait, that is not the answer.
And then when you do all of that, you get about 30 meters per second. Is that one of your choices?
Yes.
I got 5.
So there's that.